Good evening. This is a short video to discuss section 11.2 about the parabola. The parabola is the first of the four conic sections that we are going to discuss. The 11.1 was kind of the introduction to conics, and now we're going to actually jump in. So the first thing we're going to talk about are just some basic definitions. Obviously, what is a parabola? So this, I have some hand-drawn things in here that are not very good. On page 774 in your textbook, there's some good introductory drawings of this, but the parabola is something that I think a lot of you are probably familiar with. All points in the plane that are the same distance from the focus as from the fixed line of the directrix. So on this video, you can see, or the picture, you can see the V down there at the bottom of the parabola is the vertex, right, where you change direction, and then the focus is a point in the inside of the parabola, and the directrix is a fixed line on the outside. Now the directrix and the focus are equidistant from the vertex. So if you know that the focus is 2 units away from the vertex, then the directrix is also 2 units from the vertex. So the directrix is always a line. Now you're going to have either an x equals or a y equals, depending on which way your parabola opens. I'll get to that more as we go through some examples. But the focus is always a point. So you have an ordered pair for the focus and a line for the directrix. Now, something that my math lab asks a lot about is a latus rectum, which I think is an interesting name. But that is simply the line segment joining 2 points, and they lie in connection with the focus. What that means, so this picture that I have, this parabola opens up. So you can see, like, the focus might have an ordered pair of, I don't know, 2, 4. So the y value is 4. Because it opens up, the 2 points that lie on the parabola will have the same y value as the focus. And we'll do a couple examples also with this. Knowing the 2 endpoints of the latus rectum will help you graph the parabola. Sometimes you can just plot another point. This is another way to graph them. So those are some big vocab words that you need to know to work through this section. I did not do an example of finding using the distance formula, but I did type the distance formula in here just as a refresher. But this picture, so you can see on the parabola there's a point P, x, y, and that point is equidistant from the vertex and from the focus. And this is a horribly done drawing. But if you look again on page 774, there's one that's actually drawn to scale, and you can it actually looks like it. So if the focus is at A0, the directrix will be at an x value of negative x, the way we have, or negative a, excuse me, the way we have this drawn. So then the distance between would be the same. So you would pick a point, the points between P and F and P and D, D being a point on the directrix, the distance would be the same. So you will have to use the distance formula, I believe, in at least one problem. If you need to see an example, I can type one up or do one in a different video and send it to you. Just shoot me an email and let me know if you would like to see that. Okay, so the first example, let's find an equation, and I know that this is all on here at the same time, but work with me here. The easiest parabolas to work with are the ones that have the vertex at the origin. So that's where we're going to start. So if we have the vertex at the origin for this particular case, we're going to have the focus at A0. So that means the focus has got to be inside. So I usually try to graph the vertex and then the focus. Or even the directrix, because that will let you know which way it's opening. And once you know which way your parabola is opening, that can help you with the type of equation you need and so on and so forth. So hopefully you remember, if a parabola opens up, it's going to be like y equals x squared, right? That's the concept. So if it opens to the right, we're going to have x equals y squared. So because we know the vertex is at 0, 0, and the focus is at 4, 0, that lets us know that A is 4, because A is the distance between the vertex and the focus. So when you're thinking about your general equation, right, so here y squared equals 4ax is our general equation for a parabola opening to the right when your vertex is at the origin. So y squared equals 4 times 4, because a is also 4, so we end up with 16x. So y squared equals 16x would be the equation for this parabola. Now, to find the latus rectum, you've got to say, okay, so if you kind of just look at the basic sketch, and this is not, again, a good graph, but it's a sketch, you know that's the focus. If you go equidistant to each side of the focus, you will run into the latus rectum. So I would go up and down from the focus, and therefore we have to have the same x value. So this time the latus rectum will have the same x value as the focus, because it's got to lie on the parabola. So I would say let x equals 4, because that is the x value of the focus. If you put x in into your y squared equals 16x, plug x equals 4, you get y squared equals 64, and therefore your y value is 8 or negative 8. So your endpoints would be 4, 8, or 4, negative 8. And that would allow you then to have 2 points on your parabola, and you can graph the parabola a little bit easier that way. Okay, so that's the first example. I did not draw a picture with this one, but given an equation, let's find the focus and the directrix. So our equation is y squared equals negative 12x. Well, we know that this negative 12 is made up of 4 times a. So if you take, 4a equal to negative 12 here, we know that a is 3, or you could say negative 3 if you want to do the correct math. But either way you look at it, 3 units from the vertex in either direction will give you the focus and the directrix. So if you look at it, we have y squared. Okay, well, y squared means either open to the right or open to the left. And since you're negative 12x, it's negative, it's going to open to the left. Again, our vertex is at the origin because there is nothing with the y or the x. And therefore, from the origin, if you go inside the parabola, so if it opens left, you've got to go left to get inside of it. So negative 3, 0 will give us our focus, and 3 units to the right would give us our directrix. And remember, the directrix is a line. So because we go to the right, it would be a vertical line, which would be the x equals 3. Let's find an equation of a parabola given the focus and the directrix. So here, this picture, we know the focus is at 0, 4. So I drew the dot of the focus, and the directrix is at y equals negative 4. Well, the vertex is, like the midpoint between, because it's equidistant from the focus and the directrix, and therefore our vertex is at 0, 0, and that makes a equal to 4. So okay, now it opens up. So we have x squared equals 4ay because it opens up. So we need the x squared. Plug in 4 for a, and we get x squared equals 16y. So you can graph your focus and your directrix, go halfway in between them, and that will give you your location of your vertex. Okay, so we know that life is not easy, and therefore the vertex is not usually at the origin. So if we're talking about our vertex is HK. We solved it HK with circles and maybe in other places in your math past. But remember, h is always with the x, k is always with the y, no matter which is squared, which is not squared. H is with x, k is with y. So if it opens up or down, remember, up or down means we have the x squared. So x minus h squared equals 4a, y minus k. And left or right means the y is squared, so we have the y minus k squared equals 4a, x minus h. So you kind of have to keep this, the basics in mind, remembering that if it's down, the 4a will end up being negative, and if it's left, the 4a will be negative in the second one. So you got to remember of which way you're pointing and whether or not you're positive or negative. So let's write an equation for a parabola that is not at the origin, and we'll go ahead and find the lattice rectum endpoints as well, just for more practice. Find the equation for a parabola with a vertex at negative 2, 3 and a focus at 0, 3. Okay, so if you start there and you graph that, so if you plot negative 2, 3 and 0, 3, that kind of your vertex and your focus. Well, by doing that, you see that it opens to the right because your focus is inside your parabola. So we have our basic formula of y minus k squared equals 4a x minus h. So there's our basic formula. You know your focus is 2 units away. So when you graph, you have 2 units, and that allows a to be 2. So 2 times 4, we're going to end up with an 8 in front of the x minus h. Now, the substituting in the numbers, you know the vertex is at negative 2, 3. So when you have x minus h, and h is negative 2, so you have x minus a negative 2, that gives you the x plus 2, and y minus k, where k is 3. So our equation is y minus 3 squared equals 8 times x plus 2. Now to find the lattice rectum, okay, so think about it again, it opens to the right. That means our x values will be the same of the focus as they are for the endpoints of the lattice rectum. So our focus has an x value of 0. So you'd plug in 0 for x. So you would get y minus 3 squared equals 8 times 0 plus 2. 8 times 2 is 16. So y minus 3 squared equals 16. Square root both sides, and y minus 3 equals plus or minus 4. That's how you get 7 and negative 1 for your y values. And of course, for the 2 values, your x's, you plug in 0. So that's how we would get the endpoints for your lattice rectum. The last thing you're going to be asked to do is working with problems where you have to complete the square. So find the vertex, focus, directrix, and latus rectum endpoints for the following parabola. Notice we can tell that it's a parabola because only one piece is squared. So circles, ellipses, hyperbolas are totally different. But we have the x squared and not a y squared. So you want the x is on one side, the y is on the other. So we'll add the 4y to each side so we can complete the square. Hopefully you remember how to complete the square. B divided by 2 squared. So if you take 4 divided by 2, and that's 2, square it, you get 4, and that's why I added 4 to each side. So the completing of the square on the left leaves you with x plus 2 squared. And on the right-hand side, if you remember, we have 4a, and then in parentheses, y minus k. So we want to factor out a common factor, so we have a 4 out here. So once you have that, we have this in our general form, and that allows our vertex. We know our vertex is hk, so we have -2, -1. And then if you look at the 4 out in front of the y plus 1, we know that 4a equals that number, and therefore a is 1. So it opens up. We know it opens up because it's a positive x squared term. So if you draw the focus, or the vertex, excuse me, if you have the vertex at -2, -1, and you know the focus is inside, so you're going to go 1 unit up to get the focus at -2, 0, and 1 unit down to get your line of y equals -2. To find your latus rectum, because it opens up, they're going to have the same y values as your focus, and your focus has a y value of 0, so you plug in 0 for y, and you can see you have x plus 2 squared equals 4, and when you solve that, you end up with x equals 0, x equals -4, and therefore your latus rectum endpoints are 0, 0, or -4, 0. So that's your video. Let me know if you need more in-depth about any one of these slides or concepts. I can make additional videos that are different where, I'm actually doing the math, but I thought it might be a little nicer to have maybe some outlines. So I'm going to post this this PowerPoint as well as the video so you can kind of follow along if you'd like. I mean, use as much or as little as you want, but just let me know what I can do to help. So that's section 11.2 parabolas. Thanks, and I look forward to talking to you soon.